Good afternoon, everyone. Thank you so much for joining PAVE's 95th virtual conversation. I'm Tara Andringa, I'm the Executive Director of PAVE. Today's conversation is called, How Can Advanced Driver Assistance Features Improve Pedestrian Safety? October is Pedestrian Safety Month, and so we talk a lot about how advanced or autonomous vehicles have the potential to improve safety for people inside vehicles. We thought this was a great chance to also talk about how this technology can also make roads safer for people outside the vehicles, for pedestrians and other vulnerable road users. So we are thrilled today to welcome our panelist. Tarik Bolat is the co-founder and CEO of PAVE member GPR, and we are excited to talk to him today about their work. Tarik, thank you so much for joining us today.
Thank you, Sarah. Really excited to be here and share a little bit more about the sector generally and GPR in particular.
Fantastic. Really wanted to just kind of start hearing a little bit about your story. Curious, how did you get into the AV space, and when did you start looking into this world?
Yeah, that's a great question. So, we started GPR back in 2017, really under kind of the personal animus that there was technology that can make a really big dent in automotive safety that wasn't yet seeing the light of day and was outside of the bounds of some of the more traditional sensors that were being used, like LiDAR or camera, or GPS. And so we started GPR really to say, hey, if we don't bring this technology into the world, no one else is going to. And gosh, we believe it can make a really big impact in terms of safety and autonomous performance. And so back in 2017, we did that.
Great. Actually, and I think it's fascinating what you do. So could you just try to explain a little bit what GPR does? How does your product work?
Of course, yeah. So in autonomy, there are basically two halves of the brain. There's perception and agent prediction. That's the left half, let's say, and then the right half is positioning or localization. Where is the vehicle very, very precisely? And so GPR solves that second part very, very well. Where is the vehicle at any given time? And the way that we've done that is we said, rather than using a camera or a LiDAR to look at the world around you and really kind of replicate human cognition, we need to tap into new data sets that aren't available to the human if we have any hope of building a automated vehicle that's safer than human driving. And so what GPR's product does is it's a specific type of radar that's packaged underneath the vehicle, and it looks about 10 feet into the road, so below the road, and creates a fingerprint of that subsurface. Just like an HD map that you might create with a LiDAR camera, you're making that with a GPR, but you're doing that of the road subsurface. And then you're able to track that to the centimeter level accuracy, regardless of any of the conditions going on above the earth. And so it's really bridging that reliability, looking to a layer that's very stable, very differentiated and unique, that isn't subject to all of the dynamics and craziness that happen when you're driving on the road, whether that's snow or rain or poor lane markings or what have you. So really kind of crossing the gap from something that works some of the time to an autonomous product that can really work all the time.
That is fascinating. And I actually want to back up a little bit. I want to get much more into GPR in a second, but wanted to also kind of get some of your views on the big picture of the AV ecosystem right now. Obviously you have a lot of experience here and sort of see all pieces of the ecosystem. What do you see as the biggest challenges in the AV industry right now?
Yeah, that's a great question. There's basically, I would call it the long tail challenge, which is that, gosh, you spend any time in San Francisco or the Bay Area, you're sure to see lots of autonomous vehicles driving around. But fundamentally, these products are not yet good enough to be, build big businesses and big high impact products around. You might have 99.99% reliability, but getting to what we think of as the bar of 8 nines after the decimal place is 6 orders of magnitude more. That's a lot of improvement to do to get there. And so closing that gap of that long tail, whether it's in positioning or agent prediction or whatever, is really challenging. I think there's also sort of I don't know if you call it sort of a cultural aspect of the industry, but um, the industry has been built on really big claims, and I think it's fair to say that those have fallen short largely of at least what folks were saying in 2014, 2015 about where we'd be today. Um, and I think the industry could culturally take a step back and say, okay, what really needs to be done to launch these products? What aren't we doing? And how do we get there?
Absolutely. Um, and I think your point is right on in terms of 2015, kind of the whole hype cycle and the
Yeah.
where we've gone. So since you started working in AVs, what are the biggest changes that you've seen in the industry in the last couple of years?
Yeah, in the last few years, I think we've seen many more deployments, which is good news, I think. Lots of things have kind of gone from demo scale to you can actually call a vehicle in some of these places. I think simulation has gotten a lot better as well, and that's helped sort of speed things up as well. And you've also seen I guess I would call it the automotivization of the sector as well. 5 years ago, these were largely startups, but to launch a product like this, you really need to think in the design models of some of the automotive best practices, which was a little bit chalk and cheese between sort of the old automotive guard and the newfangled startups. But I think there's been a real good sort of learning process there, and some of the startups are sort of thinking about how do you launch a product like this and adopting some of those methods.
For sure. And then kind of flipping that going forward, absolutely hands down, the most common question we get at PAVE is, when will AVs be here? And we've kind of started answering it. The question is less when, but where, and explaining
Yeah.
the concept of an ODD. But I'm curious, sort of like when you look forward, 10, 5, even 5, 10, 20 years, kind of where do you see the sector going?
Yeah. No, let's maybe do a 5-year experiment, which is I think you're going to start to see more and more freight where you can get real utilization. You can actually make a business case.
Mhm.
I don't think any of the players are quite there yet, but it's in the realm of hospitability. It's a more hospitable ODD to master than some of the more complex robotaxis. And so I think you'll start to see that, and then I think you're going to see this kind of a boil the frog approach starting in San Francisco and then moving out from there, where you're going to add more and more and more. It's get better and better and better. All of a sudden, it's pretty common in San Francisco 5 years time to be hailing a driverless vehicle. And then it'll move on from there over the next kind of 10 to 15 years. Of course, some market like New York City, a much larger market than San Francisco, but fundamentally a more challenging one as well for aspects like weather and just dynamics and traffic and everything like that.
And then another, obviously we were so grateful to have GPR join PAVE. Have loved working with you and your team. Kind of in our little world, what we do is try to educate the public. And I'm curious what you see as the greatest challenges in public understanding right now. What are the kind of the misconceptions that you feel like you see most commonly, and how can we better talk to the public about these technologies?
Yeah, in terms of talking to the public, I think that it's really important to explain in sort of simple and clear terms how the AV works. What is it doing? How is it handling scenarios that you as a customer might find scary for an automated vehicle to handle. So I think that kind of just like basic knowledge, basic facts. You don't have to go into the nitty gritty technical details. You don't need to have a PhD to understand it, but really just sort of an education campaign, I think is pretty important, because I think people are excited about it, but it's such a foreign concept that I think folks really want to at least have like the simplest nuts and bolts understanding of things. So I think that's important. And then of course just safety. We all know any AV accident is a real setback for the industry, and perhaps rightly so. But making sure that rollouts are done in a way that's very safe and trust building.
Yeah.
You want to. One of the reasons that I think people are so comfortable with airplanes is they very very rarely have safety issues. But I think it's pretty well understood that, like, to get an airplane to fly, there's a pretty rigorous process around it, and And so I think the regulation sort of plays the sort of third part there, which is, we want to make sure that the regulators are communicating that there's a bar that has to be passed. All the same way that, if you're going to take a new drug on the market, you want to make sure the FDA has approved it. You feel good about it. I think a similar dynamic has to be at play here.
For sure. And the other issue that we've seen with, crashes that's been a problem in the media is not only obviously when there is a true autonomous car crash that gets a lot of play, but then there's also, because of media confusion and confusion with nomenclature, there'll sometimes be a level 2 crash that the media refers to in the headline as, self-driving car crashes. And then, then that's obviously a problem because it both teaches people that car is a self-driving car, and then I think also undermines trust and the eventual, true
Right.
autonomous vehicles, because people think, oh, those crash. It's a complicated issue.
Yeah, and you're just pausing on that point. The truth is that in the passenger vehicle context, automated features have been a real boon for safety. And so there were headlines around some government report about the number of incidents with level 2 plus systems, but like the denominator was left out. So it was X hundred. Meanwhile, how many cars on the road have these systems on is very high, and relative to human driven vehicles, gosh, it's much safer.
Absolutely. And, when you talk about safety, what are the other kind of use cases or potential benefits that you see from autonomous technology?
Yeah, in terms of use cases, so I mean, safety is thing number one. Cost, like it's if anyone's ridden in an Uber or a Lyft lately, those costs are higher than they were previously. And so, as a matter of just making mobility affordable, and still being safe, that's another one. And then you can kind of go down the list. Folks who may not be able to drive because of a disability. There's I forget the exact number, but tens of millions of Americans that are disabled, some subset of which can't drive. And then similarly with freight, how do you? I think we all probably know, folks that are on this panel and participants, that there's a huge shortage in truck drivers. And so that obviously makes it more expensive to do that business. So there's lots of different benefits that will kind of flow through society as a result.
Absolutely. Okay, now I do want to kind of talk a little bit more about sort of your product and sort of how it's different in the what you saw as the unmet need. So obviously having access to reliable and accurate information is critical. And you sort of said, we're talking about how your product is different from the traditional LiDAR and radar. What are some of the challenges that those other sensors had that you identified as this new need that you felt like needed to be addressed?
Yeah, absolutely. So, the way, maybe just to level set, the way that you do positioning with a camera or a LiDAR, for instance, is you drive a road, you create a map of the area. So you're mapping trees and signs and buildings and that sort of thing. And then you're tracking to that over time to know where you're positioned. And the reason that that's so difficult is, you need three conditions to be met all the time. One is you need to have features to look at. Imagine you're driving down Route 66 as an example. There's, just desert on either side. You're not going to be able to use that method. You don't have enough feature density, we call it. Features need to be unique, so they can't look the same. And then they need to be stable over long time periods. So if I map, on October 5th, I want to make sure that on April 5th, I'm able to, to track that. And it turns out that that's really hard to do on the surface for all the reasons you might expect. The visual environment becomes, occluded with snow or rain or fog, or some things might move a little bit, or your field of view may be blocked by a truck or something like that. And because the bar of reliability, as we mentioned before, is so high, you can't really have a product that relies just on these types of approaches. Similarly with cameras looking at lane markings, as most lane keeping systems work today. You're not always going to have clear lane markings on, but we know from customers that they want that feature to be on all the time, and they're really frustrated by it turning on and off. And so the thing that we've done differently is say, let's actually tap into this totally new data set by being the first product that's ever been able to look below the road, and that meets those conditions for doing great positioning always rich in features and stable over very, very long time periods.
Is this technology already used in other industries? I'm curious. You're working on sort of passenger vehicles and talking about freight vehicles. Is this technology already in use in other areas, or is it?
Yeah, so we pioneered the use for positioning. Ground penetrating radar is used for things like locating utilities before you dig up a road, archaeology, that sort of thing. So it's sort of a niche market.
Mhm.
The eureka moment that the company has been driving forward is really that you can use this set of imagery for a totally different application than the traditional one, and really build, basically the next generation GPS in effect.
Mhm. It's fascinating. Then back to the kind of pedestrian issue, a common concern that we hear, understandably, is people wanting to know that like an autonomous vehicle will recognize bicyclists and pedestrians and things outside of the vehicle. Can you talk a little bit about how um, sensors work to identify the things around them and then also how that compares to human drivers, like where we are now with
Yeah, so the way that it works is sort of how similar to how you might expect, which is you see something on the road, with a camera, and then you classify it into one of X number of things. Is it a pole? Is it a street light? Is it a person? Is it a child? Is it a bicycle? Is it a truck? So on and so forth. And then you can react. You're programmed to react in certain different ways. And systems have gotten pretty good at recognizing those things when they see them, at a reasonable range, and it's getting better, all the time. But gosh, there's just a lot of things in agent prediction. Is the person classic one? Person is standing talking on the phone on the curb next to the street. Are they going to cross the street or not? That's something as a human driver you can, eye that person and say, yeah, I think this person looks like he's about to take a step, or this person is just jabbing on the phone and gonna stay there. And so we have these very, very good skills as humans that is sort of the frontier of agent prediction today, which is what are all the things this person can do, and as a result, is it safe to proceed?
and then of the various weather and light conditions, what do you see as the kind of the biggest challenges, the hardest things to tackle for non-human sensors?
Yeah, so weather is a really big one. We know that even if you're not in a snowy climate, for instance, you have to be able to operate in rain. It rains in most places, some of the time, and somewhat unexpectedly some of the time. And so when we talk to our customers, their belief is, hey, we don't have a viable product if we can't operate in rain, for example. And that's a pretty tricky, that's tricky for perception. It's also tricky for doing positioning in. So that's a I would say that, and then sort of agent prediction, which I talked about, which is what is the person going to do? Are they going to run into the street or not? What does this long tail of agent prediction look like, and how do we solve it comfortably? Are kind of the two main issues.
And then wanted to just touch on data too. These are all also data processors, and kind of curious. What are some of the things that could be beneficial to society as we collect all this data about the roads and the environment all the time? Could there be benefits to road maintenance and safety and urban planning? Kind of what are your thoughts?
Absolutely. Yeah, I mean, I'll give you just an example with GPR, which is that as you drive over a road, we're able to image subterranean utility infrastructure and assets. And so you're able to create those maps and avoid digging into them, which is a huge driver of cost in construction projects. There's a famous example. I don't know how many folks are based in the Bay Area on the call right now, but the Van Ness bus line extension, took something like 19 years. And one of the reasons was they kept on digging into utility infrastructure, caused a big issue. And so, if you're always monitoring the infrastructure around you and logging that, or at least some subset of that, you're able to really see how that changes over time in an automated way. Like if an image, if you lay two images over each other and they look different, you're able to extract that difference and say, aha, what's going on here? So I think there's a pretty interesting dynamic at play for infrastructure monitoring and intelligence. And I know Mobileye is trying to launch a product in this. It's something that's core to our product as well.
And, a lot of people, we've been talking about autonomous vehicles. A lot of, actually, most cars actually now have some ADAS features too, advanced driving assistance technologies. Um, so is your product being used in vehicles for sale today as well, or are you more focused on future?
Yeah, we're focused on future, SOPs or startup
Mhm.
production. So we're working with customers for things like 2026 and 2027 SOPs right now.
Great. And are there other ways that this technology you think could be helpful or tie into to ADAS features as well?
Of course, yeah. So there's a couple of really interesting ones, and these have been customer led in a pretty exciting way, things we wouldn't have thought of. So one is autonomous valet parking. So this is on the product, I don't know if you'll call it roadmap or wish list, of pretty much every OEM, where I pull up to the airport, Logan Airport here in Boston, where we're based. I get out, go into the terminal, car goes and drives and parks itself, and then comes picks me up when the car lands. It's really tough to do this in a garage, to do positioning inside of a garage, something that
Sure.
we've mastered and demonstrated.
Mhm.
And so that's one of them. We're also doing things like enabling automated vehicles to electric vehicles to park very precisely over wireless charging pads, which is very important to getting an efficient charge from the pad. And so I think the belief, within the EV industry is over time, plug-in is going to be kind of less and less of the mix, and wireless charging to be more and more of the mix. But you've got to be able to do that very, very precisely. Similarly, along pedestrian safety and safety in general, we're because of our unique placement under the vehicle, we're able to determine if there is, a child or a pet within the wheelbase before a vehicle autonomously pulls out of the space. So making sure that nothing is, because there's not a human going to the car and operating it, where you might notice something like that. Making sure that's the automated vehicle has that type of intelligence as well.
Absolutely. Another thing we've heard about is in terms of urban planning, and it seems like, your positioning is a huge piece of this, but that humans take so much more space, like to parallel park a vehicle because we're imprecise, and that a computer can do that so much more efficiently. And when you look at one parking place, that doesn't seem like a lot, but if you take several inches off over the course of a city, you suddenly that it really can assist land use as well. Um,
That's right. That's right. Yeah. This all adds up, and you can, I haven't run the numbers myself, but I'm sure there's a pretty substantial increase in overall parking spots in a city if you're able to, really pack the cars tightly.
yeah, exactly. It's interesting. Um, and looking forward, like what are your next goals? Where else do you see, other needs that you're hoping to tackle?
Yeah, so we're working pretty broadly with a set of autonomous sort of segments. So the robo-taxi L4 segment,
Mhm.
the autonomous freight segment, the passenger vehicle segment,
Mhm.
all of which are very, very exciting opportunities. And then we're also expanding the product to other automated systems, whether that's mining vehicles, where there's a really big push for autonomy, going on, warehouse operations, where it's really challenging to do positioning accurately inside the very dynamic environment. And so, fundamentally, we think of this, as I said, kind of like a GPS, the air to GPS in a way. The natural outgrowth of all of the utility we've gotten out of GPS, just at a much more reliable and much more accurate resolution. And so we're fanning out into several industries as a result.
Another common theme we come to with PAVE is the whole, I want to call it it takes a village, that to make a autonomous deployment, it really is, industry and the public sector and academia and kind of all these different stakeholders coming together to make it work. Um, to what extent do you have to work with the cities around you? Is the product really pretty independent, or does it require certain, regulatory positions and policy positions to make it work more effectively?
Yeah, that's a great question. You always have to be working closely with policymakers when you're launching something like an automated vehicle product. So, our product in particular, it's a piece of the system, but fundamentally, we need the sector to be, if we're going to be successful, we need the sector to be able to roll out, in a pretty big way. And so we're always thinking about whether it's DOT officials or NHTSA officials, or other folks who can really be the standard bearers of what good, safe rollouts look like. We're constantly in dialogue with them and learning from them and helping educate them on the technology and that sort of thing.
That's exactly, what we hear a lot from policymakers is particularly in the local levels is, and we've done some panels on this too. We hear from, like city officials saying we want to help prepare our communities for the AV future. Like, what do we need to be thinking about in terms of infrastructure and law enforcement and all these, different things? What do we need to be thinking about now to make this work better in the future? So it seems like those cross dialogues are so valuable.
Absolutely.
Yeah. So do you, obviously you're based in Boston, and so I'm curious, you talk about the weather and things there, that it seems like most of the deployments we've seen have been in warm climates. Do you see that changing? Do you see this space growing more in your neck of the woods?
I do. I mean, it has to change. We have to get out of the Sun Belt to have, and cities that are, pretty temperate, have like very, very new builds, clear lane markings, that sort of thing. There's, you can't, if you're going to take the most efficient route from point A to point B and be able to do it in a lot of different markets, you just have to tackle these types of things. And so, I think those are great starter areas, and they've been sort of fertile proving grounds for proving out some of the core aspects of the technology. But I know, at least with the customers that we work with, they are itching to be able to, push further north and further east in terms of where they can operate, and start really making believers of, the public, of investors, of customers, of regulators, that this can be a product that can be really broadly rolled out instead of just kind of being ring fenced into a couple of, very tech forward, temperate weathered cities.
For sure, for sure. Well, and so then, in terms of the public sector, when you are talking to public sector officials, what advice would you give them about what is most, from your perspective in industry, what are the things that you think are most helpful, or actions that cities and states can take to, make this all work better?
Yeah, I think there's probably two things. One is just drawing very simple to understand and clear, bright lines in terms of what the bar for any type of rollout is going to be. Something that's really easy to understand, really easy to know if you've achieved. And then communicating to the public that this is what the bar is. This is sort of why we set it. This is how we're thinking about sort of the stamp of approval. I think those two things are good, and just excitement around it. It's always good if you see a mayor or a governor riding around in these vehicles. I mean, these we believe this will be a significant job creator over time, and sort of an economic boon to consumers and folks that work in the industry, and so really kind of getting behind that vision and communicating that to
Yeah, that's
folks.
exactly right. And I'm a big believer in demonstration events. I love getting people in a vehicle, like we were talking about. I think the best way to build trust is to have someone sort of have the experience that the car turns when it's supposed to turn and stop when it's supposed
Exactly.
to stop. I think that's, and also your point about the painting clear lines. I've also heard some others say, the most helpful things for autonomous vehicles are the same things that are helpful for human drivers to have
Yeah. Yeah. Yeah.
well-maintained roads and clear markings. That makes a lot of sense. Um, Great. Well, we are almost out of time. Is there anything else that you would like to add about GPR, your plans?
Yeah, I think just the way that we're thinking about GPR, and our customers are starting to think about GPR, is really as sort of a standard safety element, not next to like a LiDAR or a camera, or more like next to a seatbelt or analog brake system, something that you really wouldn't use a vehicle without, once it's been in there. And so, our animus for starting this company 5 years ago was to, build and accelerate the safety case for automated vehicles. And we've been really, really excited and really, really fortunate to be able to continue to do that. So I'd welcome anyone that wants to get in touch to learn more to do so. We'd be happy to update folks on where we are and how we're working with customers.
Fantastic. Well, it's great work that you're doing, and just delightful to talk to you today, Tarik. Thank you so much for your time. And thank you to the audience for joining us. We will, this will be available both as on our podcast, the PAVEcast, and on our website, pavecampaign.org. And we will look forward to seeing you next time. Thank you so much.